Good day. Welcome to our IGCSE Physics series. And we are looking at the first section of topics that you will find in your IGCSE curriculum. Here we will explain some concepts and try to give you a clearer understanding of what is in your textbook. Please feel free to pause and use the resources that we show in the slide series, and also note down anything that you think you will need in future. We hope you enjoy this series. Okay. Vernier scales and micrometers or micrometers. Whichever, once again, people have different ways of saying it. It says micrometers, micrometers, Vernier scales. Yeah, just call it what you want. It's English. Everybody does it. So Vernier calipers, Vernier calipers or micrometer screw gauge. This is a Vernier caliper. Oh, I keep doing that. This is a Vernier caliper in use. So a Vernier caliper has a little wheel that you use your thumb on, and the two hooks or the two teeth, they clamp around the object that you want to measure, and then you see exactly the length of it from the zero, which it gives here, all the way to your measurement instruments on this side. And this is quite a accurate instrument if you can get the two teeth to zero from the start, because if they are not zeroed at the beginning, then it means they are bent, and then there was also a margin of error, as we spoke of in the previous section. Okay, so how do we use the Vernier scale? The Vernier scale is divided into a 0.01 centimeter as its smallest unit. And then this smallest unit is also divided into 10 segments of 9 millimeters. And due to this, the Vernier divisions is 9 divided by 10 centimeters. So this will be 0.09 centimeters, which is its smallest measurement. So one end of the millimeter scale is made to zero with the 9 of the millimeter scale. And that's how it builds on top of each other. So therefore, if we look at my ruler again, this is a centimeter scale, right? Now, a Vernier scale is basically for the measurement between your millimeters to give you a more accurate reading of your millimeters. So if you have a measurement which is between two of these millimeter lines, then your Vernier scale will come in and it will give you a more accurate reading of your actual measurement for a ruler. But let's move on. Where are Vernier scales used? Vernier scales are used on barometers, traveling scales, and spectrometers. Next, what is the difference in scale of measurement between the Vernier and the micrometer screw gauge? So the Vernier scale actually moves on top of your millimeter measurement. So you can adjust it so that it comes in line with your object, just as you can see in this picture. You have your normal ruler in the middle, and then your Vernier scale is the one that you use a little wheel with to get in line with where your tooth or your tongue on the one side ends, and then you can get your accurate measurement. But a micrometer screw gauge or a micrometer screw gauge or gauge, whatever people call it. So the micrometer screw gauge is even more accurate than the Vernier meter. So the Vernier meter goes up to 0.01 centimeters, but the micrometer screw gauge goes up to 0.01. So if you have a scientific notation, then you can say 10 to the power of -3 for the micrometer screw gauge accuracy. What is used to ensure that an even force is exerted on the jaws? So if you look here, the jaws are the two tongues that kind of clench the object so that you can see what's the measurement between the two jaws. And the way that an even force is exerted is through this wheel here. And this wheel makes sure that both of the jaws actually have an equal power that they exert onto the object that is being measured. What is important to remember before making a measurement with the micrometer or micrometer screw gauge? It is very important because of the accuracy to 0.001 centimeters. It is extremely important to zero your micrometer. So you have to make sure that the jaws that are associated with your micrometer are exactly on zero before you start measuring. Otherwise, your margin of error is too great. So the micrometer also has two jaws that go against each other. And if these two are not zeroed, then your force exerted on the jaws will not be equal, or they will not be evenly distributed, which will throw out your measurements when you are taking the measurements of objects. Okay, so here you can pause the video and try to do these related questions on your own. And for us, if you would like us to do it with you, you can comment and schedule a lesson where we actually go through these with you face-to-face, one-on-one, and hopefully later in a masterclass. Anyway, that was all for measurements, and I really hope that this has helped you in some small way to prepare for your exams or the coming term with science. Enjoy your day.